Right, our discussion right now is based on the most famous power method that pertains matrices. Now, in this example, the matrix A with the entries minus 2, 2, 1, 1 has an eigenvalue near minus 2.5 and another near 1.5. Use the power method to find the eigenvalue near minus 2.5. Do three iterations starting with the vector 1 0 and then building up from there. Now let's discuss this because it's very, very important. And then we're going to look at the exam paper, and then we're going to look at Runge Kutta and other things. Okay, the solution to this is going to look as follows. Right, so we proceed to prepare a solution and to have a discussion around the solution that pertains this. Right, so now we look at the magnitudes of the eigenvalues. Now we note that the eigenvalue near minus 2.5 has the largest magnitude right has the largest magnitude, so we can find it right by applying the power method. To the matrix A. Right. We note again that the eigenvalue near minus 2.5 has the largest magnitude, so we can find it by applying the power method to the matrix A. Now, what then do we do here? Well, there's the largest magnitude because we are comparing the two magnitudes minus 2.5 and 1.5. And so we're realizing that just the one that's close to minus 2.5 relatively has the largest magnitude because 2.5 itself, if you get the magnitude, the absolute value of these, the modulus is bigger than 1.5. And because of that, it can most certainly be obtained using the power method and applying the power method to the matrix A. And we proceed as follows. So you have minus 2, 2, 1, 1. And we're starting with the vector 1, 0. Right, so multiplying this here, row by column multiplication, this by that is minus 2, this by that is 0, which is minus 2. This by that is 1, this by that is 0. One minus 1/2. Okay, so now we have the matrix 1 and minus 1/2, so we're going to use it. Okay, so we have 1 minus 1/2. Now 1 minus 1/2, obviously it's this vector here. But remember, we must use 3 iterations. So this is like step 1. So we are proceeding to step 2, iteration 2. And now multiplying these, so what do we get? Row by column multiplication. This by that is minus 2, and this by that is exactly minus 1, and this gives us minus 3. This by that is 1. This by that is minus 1/2, which is 1/2. Now you factor out minus 3 here, which is 1 and minus 1 out of 6. Okay, now the factoring is consistent with the nature of the vector because this vector is actually of the form it is 0, 1, but obviously when it is most certainly I need to change this. I wrote this earlier. Just a minute. Right, the vector we're referring to here is actually the 1, 0 vector. Right, so it is most certainly the 1, 0 vector. So that now the the transpose of it, or if you write it as a column vector, then it becomes indeed 1, 0, because as a row vector is like that. Okay, so or in coordinate form is like as shown before. Okay, so this is the answer. But now then we continue to take the 1 minus, now it's of the form 1 something, this vector. It's of the form 1 something. So now let's continue. Okay, next. Now we have taken the form 1 something, and we multiply, we get this, and we factor out minus 3, and this is of the form 1 something. Right, so we take now the matrix A. Which is what? Minus 2, 2, 1, 1. We multiply it with 1 minus 1/6, like this. So what are we then getting? So now this becomes exactly what? Okay, let's continue this. We've taken this, we've taken the matrix A. And then now this is the same as what? Let's multiply. This with that is minus 2, and this with that is minus 1/3. Minus 2, minus 1/3. 2 by minus 2 is minus 6 minus 1/3, which is minus 7/3. So we're getting minus 7/3 here. Okay, and then we also do this one. Okay. Now, yeah, this with that. So it's 1 minus 1/6. So this is what? It's 5/6. Like so. Okay, so now what do we get? Right, so what we're getting, okay, because we want a 1 here. It's also form 1 something. So we're going to factor out here minus 7/3. 1 and then what? Minus 5/14. Let's check this.
Hello?
If you might, yes, please.
How do you get these values?
Those values, we multiply each row here by this column vector. For example, if you multiply minus 2 by 1 plus 2 times minus 1/6, it then becomes minus 7/3. Right? But also if you multiply the other one as well, 1 by this, in other words, multiply, okay, let's multiply -2. Multiply -2 by 1, plus, so row by column, -2 by 1, and then you multiply 2 with -1/6. Okay, what's the answer? It's -7/3, but let's check if that is the case. So we have -2, but 2 times -1/6, you get -1/3. Adding these two by -3 is -6 -1/3, which is -7/3. Okay, so okay, so you continue. Right, so we got -7/3, which is exactly this, but also 1 by 1 plus this by that, we get 5/6. So with that said, then we have that, but obviously we need to make it like look of the form 1, 0. So we need a 1 here. To achieve a 1 here, what do? We factor out the -7/3, so that we have a 1. But now we need to work this out so that if we factor out -7/3, the -7/3 will affect this entry as well. But when we multiply -7/3 by this, we must get 5 here out of 6. Is it true? Okay, negative by negative is plus. If you multiply these through, 7 cancels here, giving us a what? A 5/2, which is 5/6. So this is the correct factorization. But what is the meaning of these? So we conclude as follows. And then say the eigenvalue. Oops. The eigenvalue is approximately okay, their eigenvalue is approximately -7/3, or you can write it as -2.33, because 3 goes how many times into 7? It goes 2 times. Remainder, because it divides 6, 3 divides 6 2 times, and remainder 1/3, which is the 1.33 there. Okay, so that's what we are able to get. Okay. So we continue. Next question. So I'm loading the next question right now. Right, loading the next question is just as follows. I'm actually getting it, and I'm loading it so that we can get started with it. So we're good. Okay. The next question is going to come from the past papers or, okay, one of the sources. Let me see this one. Just one sec. I'm thinking of picking the power method here. Let me see how long it's going to be. This one that's that I have here. Right. In a split second, I'm loading it and I'm going to put it on the screen. I'm going to put it on the screen. I'm going to put it on the screen. Right, this question, just one split second. Okay, it's on the same thing. I think that will be a very good one for us to sort of discuss. Right. Okay. Right, let's do this question. Another example. So in this example, we're going to be looking at an algorithm. Okay. Right. This question says consider the differential equation Right, consider the differential equation y primed minus 3x squared y squared 2, which has the analytical solution. All right. So we're really saying the solution to this is that because this is clearly separable and so on, being a separable differential equation, it's easy to get the analytical solution to it. But yeah, in this module, they even gave the analytical solution so that one cannot waste time. But this analytical solution is the exact solution to the differential equation. But what are we supposed to do ourselves? Right. So this is what we're supposed to do. Here's the question. We need to apply the modified Euler method to solve the equation. The equation up to x equal to 1, first with step length, h equals 0.2, then with h equals 0.1. At each step, I want to speak about the notion of two corrections. At each step, make two corrections. Two corrections also calculate the error. At each step. Okay. Yes, please. Okay, yeah, just give me a couple of minutes. I'm in class now finishing something. Okay. Yeah, I'll lend you. Right, so let's look at the solution to this. Right, so and look at the solution to this. We're saying consider differential equation y prime equals that. The initial value is this. We need to make two corrections using the modified Euler. How will the solution to this look like? First, just a comment on the analytical solution, but Right, so we have been given y primed. Which equals 2. The analytical solution. Okay. Given that differential equation, we have the analytical solution. Right, the analytical solution can be obtained in many ways because the y primed is like dy dx, which is minus 3x squared y squared. Okay, so if dy dx so which means dy is the same as y squared, which is minus 3x squared dx. The integral dy over y squared. Oops. Okay, I need to have one negative here. There's one negative, so just moved it to the left. So this one here is 3x squared dx. Okay, just a comment on the analytical solution, but it's not, this is separable, so we can easily solve. But in this module is not equipped with a lot of the techniques to solve differential equations. We're just approximating things here. So which is 1 over y equals, if you integrate these, it's going to be 3x cubed out of 3 plus c. Which is x cubed plus c. Okay, so at the initial value, because we know that in this problem, y at 0 is 2. Okay, y at 0 is 2 together with okay, so we continue. We are going on and on and on. Just one sec. Right, so we are in business. So now, okay, I'm writing down the result from the previous, this one. So 1 over y is x cubed. Okay, which means it is 1 over 2 equals 0 cubed plus c, which means that c is 1/2. So hence, one over y is x cubed plus 1/2. Right. Okay, we here. So this surely implies that 1 over y is equal to okay, so which is 2x cubed plus 1 divided by 2. And that means y is 2 over 2x cubed plus 1. Okay, that. Okay, so we continue. We continue. Right, so this is the analytical solution that the question gave. The sort of exact analytical solution to the differential equation at hand. But now the aim is not to find just the analytical solution, but is to use the modified Euler and to pay particular attention to the two corrections. But I want to bring in another dimension to the discussion today. So let's look at the algorithm that we use. Right, there's an algorithm that we use. So we use the following algorithm. Just a minute here. The algorithm. The algorithm is, okay, predictor. Okay, we agree that we have the predictor. And we know that the predictor is what? Okay. Okay, what is the predictor? Is y predictor, which is yi plus hf xi yi. I know this is probably boring now, but this today I'm bringing another set of formulas that we're going to be using more frequently to solve a lot of the practice problems on the modified Euler. So you need to be familiar with these notations. These are the formulas that I found in the material. Okay. Okay. So this y1 is yc1 is yi plus okay. Okay. This one is what? Is 1/2, which is f of xiyi plus f of so which is yi plus 1. We have okay, which is xi here plus h, and then y c1. Okay, these are the formulas shall be using most frequently for our predictor corrector because they are formulas that I found in the material. But also the formulas that are used with these symbols in the material for the corrector and recorrection. So this one here is for the recorrection, and this is the correction, and then a recorrection. So you can see that in the predictor, it's just the Euler method. But the corrector in recorrection, you can see that first we get the first correction, then the recorrection, the second correction will have the position of the, which is normally occupied by the predictor, it is occupied by the first correction. So we're going to actually have a look at that. But let's just look at the following here, and just to get to analyze a couple of things. But as indicated, we need to use these. So these are the predictor and corrector, but they constitute the algorithm. So where F, we have 3x squared y squared. Now, need to have the following. The predictor, and then the corrector. Okay. I want to do something. I'm just pausing because I'm thinking. Right. So the predictor, I want us to do the predicted values. So this is that with y at 0 is 2. There's something we did last time where we're just doing these modified Euler without like writing too many steps and just putting everything in our table. So, or filling in our table. So it's that we need to do today, just to expedite processes. So we're going to say y predictor is yi plus hf xiyi. The corrector, which is xiyi plus f. Oops. Plus h. Okay, so yp. Okay, and then we're also going to do yi plus 1 because that is the algorithm. And then this one is yi plus half h into f of xi, yi plus f of xi plus h, yc1. Okay. Can do the predicted values quickly. We have xi, yi, f of xi, yi, And then, yeah, normally we do alongside like this. But I feel that the corrected will just have a bit more because there are two corrections. So let's just start with this. So if you look at the fact that y at 0 is 2, which means that we have 0, 2. And then now you'd have f, which is this. So f x I y I, it means you must multiply these two things and then multiply x squared by y squared by minus 3. So obviously, because the x is 0, so you multiply this, you get 0. So this one is going to be 0. And then what is the predicted? So the predicted value will be actually, according to this one is going to be 0 by whatever h is going to be. This is going to be 0, and then it's going to be only be yi. So the predicted is going to be only 2. Okay, so let's do a little bit more. As we continue with the predicted, which is xi, yi. Yp 0, 0.2, 0.4. Okay, because h is 0.2. So moving in steps of 0.2, then we add another 0.2, then we add another 0.2, 0.6, 0.8. Okay, you add another 0.2, which is 1.0. Okay. Now, what is this? Okay. Okay, I said I'm doing this because of the corrections and recorrections. Okay, I'll have to simultaneously extend these to other things. Now, so you have xi plus h. Now having xi plus h, because I'll have to make use of some of this here. See how well we can do this. And just squeeze everything here. So obviously on the other side of these, which I'll have the, because we have the predicted, and then here we have the corrected values. Right, so we have the xi plus h. So okay. Now, if we have this one, then you can have the f xi plus h yp. Okay. Then you can get, we shall get yc1 After that, we shall get F. Xi plus H, YC1. Yi plus 1. Yi plus 1. Okay, so yeah, we've squeezed everything. Let's just practice, okay? So like we saw before, this one here is always one step ahead. So because it's xi, this was xi plus h, meaning that at the first point, you're going to have 0.2 because it's plus h. So for instance, if you have x0 plus h, then it's going to be 0 plus h, which is 0.2, then is 0.4, 0.6, 0.8, 1.0. Then right now, then you have, okay, we've seen that because y0 is 2 initial value, it means that x0 is 0, but y0 is 2. The function itself, the differential equation, is this one, meaning you multiply these two things. You square this because it's x squared and then y squared and then multiplied by minus 3, meaning we square 0, we get 0, multiply by 2, we get 0, and then multiply by minus 3, getting a 0. What is the predicted version? The predicted version means that you have this is the predicted version. For the predicted version, you take this f, you multiply by h, and then multiply by yi. So you take h, you multiply by this, then multiply by yi. So which means it is 2. Now, what do we get at this point? Okay, let's do this one. So to get this one now is the same. You're using the f function, you're using this one, but you're just squaring the x and the y and multiply by minus 3. So it means that we shall square xi plus h, this one, and then we shall square this one, and then multiply by minus 3. Right. Let's just do that. Mm-hmm. I need to get the calculator, please, because just to avoid mistakes. Calculator, can you help us to get better answers, a bit more accurate? Okay, now, okay, so which means that then you have x, you'll have this one squared, so which is 0.2 squared times, delete. Okay, just need to make sure that this is not is doing the correct things here. Okay, right, so you have 0.2, you square it times, all right? And then now you would have the y predicted, which is 2, and you square. And what is the answer? Minus 0.48, yeah, that's the correct one. So which means that here we're getting minus 0.48. Right, and then we get YC1, the first correction. Right, the first correction is going to be the fxiyi and then this f and then multiply by half h and then plus yi. So half h is clearly because it's 0.2, so half is going to be 0.1. You just multiply the f's by 0.1 and then you add to yi to get the first correction. Let's just do that. So here's the first f and here's the other f to get this. So you add these up and then you multiply. If you add this, you get minus 0.48 and then you multiply by 0.1 and then you add 2. Okay, so we start with 2 yi plus half of h, which is half of 0.2, which is just 0.1. And then we multiply that by the sum of these. So this is 0 minus 0.48. Oops. And then you close. Oops, the point is not there. Okay, and then you close. Okay, which is 1.952. Let's compute 1.952. 1.952. Okay, then you have f of this. Okay, f of this, we need to do f of this. What is f of this? F of this is going to be exactly this function, minus 3. You square the 0.2, but you multiply by the square of this. Okay, and then that is going to help us to get the recorrection. So, which means that we're going to launch the calculator again. And then we shall do this f. So to do the f, we do minus 3. Right, so you do 0.2. And then you square it. You multiply by the first correction. 1.952. You close and then you square this. Okay. Right, so it becomes minus 0. That minus 0.457. Minus 0.457. Right, so minus 0.457. Okay, then let's look at the next one. All right, now you do what? Okay, you do the same. So now obviously we are looking at the recorrection part, and the recorrection part means that we're going to add the f's, this f, and then the first f, and then 0.1, and then we add 2. So we add the f with c1 and then the f with no c, no yp, and then multiply by 0.1. Let's check that. Okay. We add this f together with this one here, and we multiply by 0.1, which is half of h, and then we add 2. Let's launch the calculator. 2 plus 0.1 into this one is 0, and then this one here is minus 0.457. Like this, and then you get the answer, which is 1.952. 43, 1.9543. Right, so you can see that it is exactly 1.9543. Right, so okay. Next. Like we know, obviously, once we get this value, it's the value we use for the next prediction. So meaning that now when we do the next prediction at the next step, we're going to use this value. So we use 1.9543. Right, and then we continue because we have these two now. We multiply them and multiply by -3 because that is the order. So we're going to do this here, which is -3 into, which is 0.2. Okay, 0.2, and then you square it times, and then you have 1.9543. Okay, so what are we getting here? Which is minus 0.458, minus 0.458. Minus 0.458. And then, what is the predicted? To get the predicted, we do, so we take this one. Predicted YP, Y predictor is the F times 0.2 times YI. So it's YI plus, okay, launching the calculator. So the predicted is going to be 1.9543 plus, that's YI plus 0.2 into F, 0.458, like this. 1.8627, 1.8627. Right. 1.8627. Is that correct? 1.8627. All right. Now we got this one. Then the next thing is we must get the F. So F of this and this. So which means that it is minus 3 times, which is 0.4 times YP, 1.8627, which is 1.6654, 1.6654. 1.6654. 1.6654. Then now you're gonna do the first corrector. The first corrector. Right. Oh, quite a boring exercise, but yeah, time consuming. And now this is right. So obviously you can see the first corrector. We add the first Fi with nothing, and then the F with the Yp, and then we multiply by 0.1, and then multiply, we add to Yi. Okay. I'm sorry. We're just practicing with this, but it's time consuming. And this is a very important skill we need to do these tables. Okay, right. So we said we do this one, and we add the F, and then okay. First we take Yi. Then we actually, because it's a correction, so it's half 0.2, which is 0.1. Into, now you take this F, which is minus 0.458. And then you add to that this one of the predictor, which is 1.6654, which is 2.12074. 2.12074. Okay, something strange happened. Okay, look, okay, it's 2.12074. Okay, that's fine. Two point one two zero seven four. Okay, then now you're gonna have this one. So you're gonna take this one and this one, multiply by -3. Okay. All right. So you just forgive me. This is just boring exercise, but just some practice, but same thing. Okay. So now you take this X. Okay, you were filling this one here. This means that you're gonna take this one, and then you're gonna take this one. So X, which is 0.4, squared times, which is 2.120 74. Okay, which is minus 2.1588. Minus 2.1588. Minus 2.1588. Okay, I'm doing this question because there's another one that came in the exam in November. So it's the same, but yeah, with this, the method is the same, but just that one has two differential equations and a bit more work. But this one has one differential equation. So that one means two differential equations, like we indicated last time, need to solve for both x and y. But now we come to this one. So this one is exactly the same thing, but you take what? For the yi plus 1, which is a recorrection. Yi plus 1, take the first one, the yc1, 0.1, and then you multiply by yi. Okay. Let's do that. Which is this one. So you're going to take first this one, 1 point. Taking yi, 1.9543. That is our yi plus half of 0.2, which is 0.1. Half of h is 0.1. And then you take the first one, which is exactly this one here, minus 0.458. And then now you take this and you add to this one here. So, which is minus 2.1588. You close 1.69262. 1.69262. 1.262. Now you take this one and you bring it here. 1.69262. Then you multiply everything here. 1.69262. Okay, then you include this one. So, which is minus 3 into, okay, we have the x here, which is 0.4. And then you square that times, okay, and then you have the y, which is 1.69, 262. Then you close, and then you square, equals, is minus 1.37518. Minus 1.37518. Right, so is minus 1.37518. Okay, now the predictor is easy because you always say yi plus hf. So you're going to take yi. Right, what is yi? Is 1.69262. Yi plus h, 0.2 times f, 1.37518. Which is 1.417. 1.417584. 1.417. Right, so this is 1.417. Okay. 1.417. 584. 1.417. 584. Okay. Yeah, do you say 584? Something like that? Is it? I'm forgetting sometimes. Just one sec. Right. Yes. Okay. We have exactly that there. All right. So we continue. All right. All right, so continue. So, okay, we're finishing, my goodness. Just, uh, okay. Right, so now we have this one, which is exactly this minus 3, because it's minus 3x squared y squared, so it's minus 3v squared, and then yp squared, and then put it there. Okay, minus 3 times x squared. But the x plus h is exactly the 0.6, so you have 0.6. And then here you have the yp. What is yp? Y predicted is this one, which is 1.417584 minus 2.1703 minus 2.170. Okay. Minus 2.170. Hey, forgive me, please. I did not do this myself during my own leisure. So it's minus 2.170, then 3.1, then 3.1. Okay, then y corrector, the first corrector is as usual. So we take actually yi, and the first corrector, you take yi, half of h, then the first f, xiyi, and then yf of the predictor, and you get y corrector, first corrector. So first correction. So let's just do the first correction. Right, so to do the first correction, we're gonna do that. So we're gonna take the 1.69262, okay, plus half of 0.2, which is 0.1, 1.37518. Okay, and then okay, that is the f, and then you take the predictor. Minus 2.17031. Okay, which is 1.3380. 1.338051. Okay, so 1.3380. 1.338051. 1.338051. All right, so now you have the f, which is exactly this one by this one squared multiplied by minus 3. So, okay, we are rounding up this part and then moving to other things. Minus 3, so it's going to be here as part of the video. You can practice with it, but it's not difficult really, but it comes in the exam, that's the thing. So either Euler or modified Euler. But this is the modified Euler with 2 corrections, very important for exam study. Okay, so you have here the 0.6, you square it. And then after you square it, according to this, you take YC1. 1.3380. 1.338051 squared, which is minus 1.9336. minus 1.9336. Minus 1.9336. Okay, so looking at minus 1.9336. What am I doing now? I wanted to see the thing, the calculator. Right, so it's minus 1.99336 is okay. So the last one now is to do this one. So we start always with the yi, which is 1.69. Oops. 1.69. 1 point, yes, 1.69, then we do 262, right? And then plus half of h is 0.1 into this f. So it's minus 1.37518. Okay, so is this f, and then now we take the other one with the first correction. So is minus 1.9336. Then you close, and then obviously what we're getting is 1.361742, 1.361742, 1.361742. Okay, so which is exactly 1.361742. Right, you take that one, 1.361742, and then you multiply, you put everything here. So minus 3 into the x, 0.6 squared into the y, which is 1.361742, you square it, minus 2.002, minus 2.00269, minus 2.00269. Minus 2.00269. It appears I have the right one. Okay, so we're finishing this table, please. This is important for exam revision. Right, 2.00269. Then we're going to come to the prediction. So let's do the prediction quickly. The prediction will always take care of this one, which is the 1.361742. Okay, so it's always yi plus h. H is 0.2 into f, which is this one, minus 2.00269, which is 0.96, 0.961204, 0.961204, 0.961204. Zero point nine six 1204. Right. Zero point 0.961204. So now, okay, we continue, please. Right. Okay, we're continuing. And then now what we have here, we have this one. So is actually this x plus a xi plus h squared, and then the yp squared, and then multiply by -3, and you plug in the results. So let's do it. So 0.8 squared, which is 0.9. 1204 squared, which is minus 1.7739. Minus 1.7739. Oops. Minus 1.7739. See, I'm even forgetting that because this screen jumped. Need to make sure I'm putting the correct value there. Minus 1.7739. Okay, right. And then now you're going to get this corrector. Now the first correction is the corrections are always yi, which is 1.36, 1742 plus h, half of half h, 0.1. 2.00269. And then, okay, that's the F. And then you have this one of the predictor, which is minus 1.7739, and then you close. 0.984083. 0.984083. Okay? 0. 0. I'm forgetting. Don't need to write wrong things here. 0.984083. Yeah. 984083. 984083. Okay, then now you have f of, okay, need to do the f. So we're going to take this one minus 3 times this one squared, and then yc1 squared. So minus 3 into x, which is 0.8 squared, into, now you're gonna get this is 0.98 4083 squared. Minus 1.85936 minus 1.8594 minus 1.8594. All right. 1.8594. All right. See this one. Okay, we're finishing, and then we're going to apply this minus 1.8594. And then now the last but not the least in that row, and then we just have, hey, this is just useless stuff. But yeah, we can compare this. Okay, yeah. I have the results, computerized results of this. So now with this, actually, I see that is yi plus 1. So yi plus 1 is going to be yi, which is 1 point. 1742. 0.1 into minus 2.00269 minus yes, okay, we are just adding these things, so it's minus 1.8594. 0.9755, 0.975533. 0.95, rather 0.975533. All right. 0.975533. 0.975533. Okay, so at this point, oh, okay, need to multiply this. Right, so which means is minus 3 into, okay, 0.8. 0.8, and then you square it, and then this one 0.975533. This is the same as this, and then you square it. Minus 1.8272 minus 1.8272 minus 1.8272 minus 1.8272 minus 1.8272. Y predictor. Right. So the Y predictor, you take the yi, which is exactly this one, which is exactly 0.975 7 5533 plus 0.2, which is h, times f, which is minus 0. Oops. Times f, which is minus 1. 1.8275. 0.610033. 0.610033. 0.610033. Okay, now if you have these, then you deal with the other one. My goodness me. Okay, I need the calculator. I'm just pressing other things here. Okay. Okay. We need this one, f of xi plus h, then y predictor, which means that is minus 3 into, this is 1.0, so it's like 1 squared, just 1. You can just leave that out. And then now we have the y predictor. What is the predictor? Is this one. 0.61 which is minus 1.830099. Minus 1.830099. Minus 1.8300. Minus 1.830099. Okay. And then now, okay. And then you have this one, the corrector, the first corrector. So for the first corrector is the same thing. Okay, we're done. Just the last bottom row. We're not going to even finish the last bottom row. We don't need to finish it. Just the first entry. Okay, so now, what is this? This is exactly yi. Zero 0.975533. Huh? Let me see. No. Right, it's this one. So we're gonna do your is yi 0.975533. That is the yi, but we add half of h, half of 0.2, which is 0.1, into this f, 0.1 point. This f is minus 1 point. 8275. Okay, so get this one. Which is minus, okay, yeah, it's this one. 1.830099, which is 0.609. 0.609. 0.609. Zero point 609 7731 7731. Right, so now we have this one, and this one is actually if is this one yeah, it's minus 3 times this squared, and then this one is squared. So obviously this one is just 1 squared, so it's just 1, no effect. So which means that on our calculator we're gonna do minus 3, 1 squared, and then this one squared, which is 6 point, no, 0 0.609, 609, 7731. Okay, it just estimates squared. Minus 1.1154697. Minus 1.1154697. Minus 1.1154697. Okay, I might have made a mistake. I'm going to check. Minus 1.1154697. Then the last one there, which is going to give us the answer to that we want to this, meaning we're done just once we fill this up. So at this point, we need this yi plus 1, which is exactly the recorrection. But the recorrection is done by using 0.975533. 0.975533. And then, okay, that's our yi plus half h, 0.1 into. And then this one is minus 1.8275. 1.8275. And then this one minus 1 point. Okay, what is it? 1154, and then 697, and then you close. 0.6812. 0.6812. 0.6812. Okay, 0.6812. 3603. 12. 3603. 6812. Okay, so now what is the answer? So obviously this one here is a very interesting discovery. And then what will obviously the discrepancy be on account of this? So very, very interesting. So this is what we get. So, I mean, what this is saying is that y at 1.0 is approximately 0.68123 Okay. Yeah, that's what this is saying. Okay, we're gonna take a look at that, but yeah, that is what this is saying. So with that said now, okay, this is a predicted corrective. All right, doesn't matter. All right. Now, there's another question that we're gonna study. And I want us to spend some time looking at the following method, the Runge Kutta. So we hinted a little bit on the Runge Kutta last time, but we need to spend a considerable amount of effort. Okay, continue. All right. Right, a couple of other things obviously we're going to discuss, but I want us to look at the Runge Kutta. Okay, so the Runge Kutta has a couple of different orders, but I want us now to speak about the Runge Kutta of order 4. Runge Kutta of order 4. Okay, we're continuing on the Runge Kutta. Right, we want to speak about the Runge Kutta order 4 result. Right, speaking about the Runge Kutta order 4, W0 is alpha, K1 is HF, TR, K2, TI plus, K2, K3. Okay, let me see. K1 is this, K2 is that one, K3. This is 3, because 2 is that one. And then this one is 4. 4, which is Ti plus 1. And then Wi plus K3. Wi plus. For each I 0, 1 up to n minus 1. So this one is called the Runge Kutta order 4. Okay, so continue. This is called Runge Kutta order 4. And obviously, in light of this, I want us to, this order 2, Runge Kutta order 2 is also called the modified Euler, which is what we've been talking about. Yeah, but we'll elaborate on, I elaborated on that, but yeah, with necessity. But I want us to use order 4. And let's give an example as these things come in the exam. And I'm going to give 2 examples, one on this and another example on Runge Kutta of order 2. The example says use the Runge Kutta method of order 4 with h equals 0.2, n equals 10, and Ti equals 0.2i to obtain approximations. To the solution of the initial value problem. Initial value problem. Solution. Right, use the Runge Kutta method of order 4 with h equals 0.2, n equals 10 in Ti. I gave this problem last time, but I want us to discuss the solution to this problem today. Right, so in discussing the solution to this problem today, first things first, we look at how we can use this Runge Kutta. We start with W0 is alpha. In the case of our problem, what is the initial value? It is exactly Y0 equals 0.5, which means we can say W0 is 0.5. K1 is H. So is H f of TIWI. What is K1? We continue. I feel that, okay, we're just gonna get the difference equation here. We're just gonna get difference equation because the table is gonna be very long. All right, so now, for example, if it is K1 we're dealing with, and H is 0.2, and then now we're dealing with T0, W0. Right, so T0 is 0, W0 is 0.5, which is so now, which means we have this. But what is f? The f function is the differential equation. So now what is the differential equation? So we can just write it down. The differential equation is this one. So which means we have, this is a function of two variables. So which means that it is f of TIWI. So y primed is this. Y minus f of TIWI, which is WI squared TI squared plus 1, which means that it is 0.5, 0 squared plus 1. So but it's a 2. Oh, okay, it's too congested. Which is 0.2. Okay, so this is TIWI 0.5 minus that squared plus 1. Okay, so this one is like 1.5 by 2 by 0.2, which is 0.3. Yeah, we're just going to do difference equation. So let's do K2. According to the Runge Kutta order 4, K2, it's going to be exactly this one. So if it's computed it precisely T0 plus H over 2, and H is 0.2. Okay. Right. Okay. One has seen the formula, so which means that this one is going to be exactly H. F of T0 plus H over 2. W0 plus half K1. So it means K2 is 0.2 for this question. And then, according to this differential equation, you'd have to take the F, and F is this, so it's going to be the W squared, which is 0.5. Half of that, which is 0.3 out of 2, and then you square this minus T0, which is 0.1 squared plus 1. Okay? Okay. So this one, yeah, H is 0.2, but over 2, which is 0.1 squared. The T0 is 0, and then 81. So what's the answer to this here? Okay, need to check this up. Just use the calculator for this. So you'd have 0.2 into 0.5 plus 0.2. 0.2 plus 0.3 squared minus 0.1 squared plus 1. Okay? 0.22. That is a small thing I need to check here. So that's going to be 0.1 squared, and then the W is going to be 0.5. Let's see. Half of K1, which is W0. W0 is 0.5 plus. Okay, here's a mistake. Oops. Wondering why this is giving me a different answer. This one should have been 0.5 here. But still, I'm not getting the result I expect. So 0.2 into 0.5, then 0.3. I hope this is done well. All right, there's a small thing. H is 0.2, and then it becomes 0.1. 0.65. Let me check this one. W0 plus K1, which is 0.3 out of 2. Yeah, which is 0.65. So this is going to be just trying to check what's happening here. So this one here for K2, AH is 0.2, then this one is T0 is 0 plus H, which is 0.1. And then the W0 is 0.5 plus H, which is 0.65. Because 0.5, okay, see. Okay, so W0 is 0.5 plus 0.3 divided by 2. Divided by 2, which is 0.65. Okay, this is okay. But I'm trying to trick a small error here. So if this is the case, and now we can use it here and then say, in this function, K2 is 0.2, which is okay, which is exactly the f function of these. The f function of these is, according to this, 0.65. squared. According to this, then minus the first one is 0.1 squared, then plus 1. Let's check what answer this is going to give. Okay, I'm expecting give an answer, but it's like this is not really yielding that answer. I'm trying to see why. Might be an error in the book. So 0.2 into 0.65 squared. Okay. 65 squared minus 0.1 squared plus 1. Okay. It appears that there is a small error in the book. Ah, no, I made a small error myself here. Okay, because there's no square here. Ah, there's no square here because it's just y here. There's no square here, so there's no square here. Square there, no square here. Okay. Oh, so this is going to be 0.65. Okay, we continue. Minus 0.1 squared plus 1 times 0.2. 0.328. 0.328. Zero point 328. Okay, we continue. And then we have K3. Right, so K3 comes from exactly this one, but we're going to do it for T0. So it's going to be K3HF. And then it's going to be T0 plus H over 2. W0 plus half K2. Okay, so H is 0.2. We're finishing, please. Then, according to this, T0 is 0 plus, okay, but we have the WI, so which means that this W0 is 0.5. Just to do it like that, to avoid too many mistakes here, and just use the F notation. So which means that T0 is 0, then H over 2 is 0.1, because H is 0.2, and then W0 is 0.5 plus half K2, which is half of this. What is this? W0 is 0.5 plus 0.5 times K2, which is 0.328. 0.664. Yeah, that's correct. 0.664. Which means at this point, if it is 0.664, then we use exactly this notation. 0.2, can start writing at the far end. Which means K3 is 0.2 into, so the WI is 0.664 minus 0.1 squared plus 1. Zero point 0.2 into 0.664, 0.1 squared plus 1. 0.3308. 0.3308. 0.3308. So that's this one. Okay, the last one, K4. Right, K4, the formula I wrote it first is this one, which is Ti plus 1, Wi plus K3, which is K4 HF of T1 W0 K3. Now K4 is 0.2 F of T1 is going to be T0 plus H, which is just 0.2. W0 is 0.5 plus K3, which is 0.3308. Goodness me, 0.2 into 0.2. 0.8308. 0.2 and then, okay, so it's 0.8308 and then minus 0.2 squared plus 1. We're using the relation f of ty is y minus t squared plus 1. So, okay, so you're going to use the calculator to get this one. 0.2 into 0.8308 minus 0.2 squared plus 1. 0.35. So 35816. Right, so Wi plus 1, which is the difference equation associated with the Runge Kutta of order 4, is Wi plus 1 is Wi plus 1 over 6 into K1. We're finishing, please. 2K2 plus 2K3 plus K4, meaning that this Wi plus 1, for example, can be, you can get the difference equation equals Wi plus 1 over 6. What is K1? Which is 0.3, 0.2. Okay, K2 is 0.328. K3, 0.3308. K4, 0.35816. So which means that the Wi plus 1 is actually Wi plus these things. So 0.3 plus 2 times 0.328 plus 2 times 0.3308 plus 0.35816, which is 0.329, 0.32929. Right, so this one here, 0.32929. 33. Right, from this is a difference equation, very easy, and then we can be able to get W1 when I is 0, which is W0 plus 0.3292933. Oh, which is 0.8292933. Okay, so yeah. Now we're going to finish this tomorrow to generate the table associated with the Runge Kutta of order 4. And we found W1, but in the same way, we need to find the rest of the W's. But because now we need to find the rest of the W's until we are able to estimate the required result. So in other words, here was the question. Approximate to y at 0.2. Approximate to y at 0.2. Right, if you approximate to y 0.2, it means that you just take W1. So which means y at 0.2 is approximately W1. And what is W1? Is 0.82. Nine. 0.8292933. Okay, so we've been able to estimate using the polynomial, or rather Runge Kutta order 4. Right, we're going to continue tomorrow and explore the applications of Runge Kutta of different orders to solve problems. So for today, I must thank you for joining us. I'm going to upload the video in the next couple of minutes. I might be able to see you tomorrow. At about half four. Half four is the best time for tomorrow. I'll just check the load shedding, but I need to check the load shedding for tomorrow, just because now is what sometimes creates a change in the time. Okay, there are a couple of too many things obviously you still need to discuss and build confidence and experience. All right. Anyway, very unpredictable load shedding. Okay, I'm suggesting, but you see, this is confusing to me because there might be load shedding at 4 tomorrow. But again, okay, I'm proposing that the class is at 4 p.m. But I can suggest some earlier time. So please be prepared in case the load shedding. I might push it to some earlier time, but I don't want to make promise of an earlier time. Or if the load shedding then happens around 4 and is confirmed, then I might have to put it either to an earlier time or to a later time. But I think it's fair to a later time because now to an earlier time is not fair to you because you might be doing something else, and then suddenly because you're planning, you're thinking that at 4, that's when you're going to have the class, and suddenly the class is at an earlier time. But yeah, I'm going to communicate to you tomorrow, but I'm suggesting 4, but load shedding in the neighborhood of that time will potentially create a change in the time. So, but I'm going to let you know of the change, but I'm proposing 4 o'clock. Okay. All right. Thanks then. See you tomorrow at 4. And goodbye.